hell happened? Yeah, so this one here, this NPU 6050, which of course they don't recommend using anymore. So this is a gyro and accelerometer, and it's really, really cheap. So, and it's got really good documentation, and it's very simple to use. It's I²C, and it gives you 6 directions. So you've got the X, Y, Z, obviously with the you got the X, Y, Z directions, and then you've got the rotation around each of those axes as well. So you can figure out the acceleration in any of those directions, and the gyroscope as well. So the rotational acceleration. And then they're obviously suggesting here to add a 3-axis compass so you can tell which direction it's facing. And then you can have your pi sitting here. But essentially the idea is you can measure acceleration and do whatever you need to do with that. So what I was using it for, I think maybe I posted that in the Facebook group, is my punching bag application. So you punch the punching bag and you sort of have a fake fight with an imaginary opponent. So this works really, really well. Just a really good piece of kit. The reason why they're saying not recommended for new designs is there's just better versions out there. There's nothing really wrong with this one. It's very good. But there's just better versions. Like there's this one. Sorry. Yeah, I think we have lost it. Yeah, so there's this one, for example, which is a 9-axis. So it's the same sort of idea. So they've got the 3-axis gyroscope, the accelerometer, then they've got the compass included. And even the cheaper one I've got, the older one, has some sort of digital motion processor. So it's a full inertial measurement device. So it'll tell you the direction. So it gives you the absolute direction of where it's facing as well by looking at that functionality. But I was just using this one just for accelerometer itself. But you can imagine sort of picking up, vibration or things like that. So that was a really good little piece of kit. I²C, the circuit, you don't need a circuit for it. You just sort of solder an IC socket and you plug it in and your job done. And it's got through hole and surface mount. And then the other one I want to quickly mention is this VL53L0X. And this is the LiDAR I was talking about. So it just has this time of flight. So all it's doing is sending out some light and measuring when it comes back. So like it comes out of this one and measure when it bounces back, how long it takes for that response to come. Yeah, so it's here, this surface emitting laser. And this is the one I was using in my water software miner. So this is only cost £4 for one of these. It's mounted on a breakout board. So again, it's just I²C, measures up to 2 meters, and you can adjust it if you want higher resolution. So you want to go to 1 meter, or if you want it to go faster, there's different things you can do. So you just send it information and ask it to change its mode. Just like this one, this accelerometer, you can tell it to measure 2G, 4G, 8G, or 16G, depending on what you're actually trying to do. Yeah, so down here, you've got these settings here. And because it's a very popular chip, there's lots of good documentation for it. So these are the 2 things I would recommend taking a look at. You're trying to measure some sort of distance up to 2 meters, or you want to measure acceleration for some reason. And it does have things like, tell me whenever the goes over, 4G or something like that, just so you know it's been hit or whatever, or damaged, or there's some reason why you want to know that somebody's opened a door, for example, or something like that. Yeah, so that's my 2 chips that I really like.
Richard, is there a time of flight sensor which will do longer range? I need about 4, maybe 5 meters.
I'm sure there are. I don't know which one it would be. Like, I don't know if some companies like put lenses and stuff on that to make this work for longer distances. I don't know how that would work.
Yeah, the one you're talking about, Richard, has 2 modes. It has a high resolution mode at 1 meter,
yeah.
And then you can switch it to a low res, which is 2 meters.
Yeah.
But I've not come across certainly any cheap ones that go beyond the 2 meters. Normally, beyond that range, you're actually talking LiDARs, which are obviously a hell of a lot more expensive. So the only thing
sorry, go ahead.
No, I was going to say the only thing I found that you could go beyond that was ultrasound, but then ultrasound becomes very less targeted, because it spreads out so much. Whilst you can detect stuff, you can't focus it. Whereas these are ideal for being able to focus. Certainly in terms of a 1 meter, and even at 2 meters, you can generally know where they're pointing to. They actually create a cone of laser light, which spreads out as you go as it gets further out. But it's still quite small. It's about 5 to 10 centimeters at the far reaches, so you can generally know what you're aiming at. Whereas ultrasound, it's a lot wider. Yeah, and you don't get much. I didn't find you get much jitter either. Like, there's not a lot of your measurements don't go all over the place. I mean, some of them are a bit off, but it's reasonably consistent and accurate. Yeah. The laser one is definitely much better. This is a brilliant bit of kit. I found these are fantastic. Yeah, and for £4, it just can't go wrong, right? Yeah, exactly. Yeah. Accelerometers, I just find they're good fun. I just sort of like having a accelerometer attached to your Pi and just moving your Pi around and just looking at the different accelerations. Even if you just did I think at one point I just did like a pedometer, just measuring steps. It was really good fun. One project, I got a couple of accelerometers. One project I was intending to do when we were still doing physical meetups was make a sort of handheld Bluetooth mouse that I could move my hand around and it would move the mouse cursor on the projection screen. But now all my presentations are done sitting at my laptop, so I don't need that anymore. So I haven't built it, but I have all the equipment. Maybe next year. A Harry Potter wand. Yeah. So I have a slide remote control for changing slides, which is very nice. But I also wanted to be able to move the cursor with the same style of device, not just change slides.
Best of luck with that one. Having used some very expensive gyro mouses and then being utterly frustrating. I was assuming that it would be about the same level of badness. Yeah, from my experience, it's a low bar, but I don't imagine it's an easy one to fix.
It's interesting. Yeah, I mean, there are these things called I think they're called Kalman filters that help stabilize the readings that come back from an accelerometer. But they are computationally expensive, I think. Well, this MPU6050 has one in it. Yeah. Is it really? Yeah, you just tell it to turn it on. Just tell it to turn it on.
As well. What about using a Wii remote?
You say
they're supposed to be quite accurate, and they're Bluetooth enabled.
They've done interesting stuff with a lot of the gaming equipment people have done.
You can hook up a Wiimote quite easily to your Pi. I've done that as well.
Yeah.
You've got.
So, did you have some hardware you want to share?
So I can show you what I like using. If you stop your screen share.
It is for Pis, right? It's not something else.
It's this. So it is an Esp8266 board, which you can have. These I get for about £4. I think you can get them for a lot cheaper. And it's basically a Wi-Fi. It's a little microcontroller that has Wi-Fi on it. Only IPv4, not IPv6, unfortunately. and I use that to connect back to the pies in my house. So, for example, I have a temperature probe attached to this, and it's good for like really low end, cheap. I just want to stick something on Wi-Fi. I don't want to be messing around with other radio networks. And I put a few projects there. I would probably, if I could get Pi Zeros, I would probably use Pi Zeros, but they're very often out of stock, and they cost a few times more expensive. So the main language I program this in is Lua, but I think you can do the Arduino SDK on it as well.
So Ben, is that the Wemos D1 Mini?
Yeah, I think so. It doesn't actually say on it. Oh yeah, it does. D1 Mini, yes.
Yeah, that's the ones I like. Yep.
Yeah. So it's fine. It's nothing special. The Lua runtime quite often will just crash if it runs out of memory and stuff like that. But then it reboots. So fine. I just want it to once a minute talk to a temperature probe, get the temperature, send it to the big mothership, which is a Raspberry Pi. It's nice for that for me.
And then
So
reboot so you don't run out of money. You reboot so you don't run out of memory. You know.
Yeah, I actually most recently, I've never done it before, but this last iteration that I built a few weeks ago, I put in addition to a temperature notification, it does a reboot notification. And I was surprised to find how often it has been rebooting and without me even noticing at all, because I guess unless I was looking at the precise timings of did you send this exactly 60 seconds between, then I wouldn't even notice it. Yeah. So sometimes it goes 2 or 3 days. Sometimes it seems to reboot 5 times in a few minutes. I haven't worked out if that's a software problem or a power supply problem.
It's
but it's
probably
actually
networky where it's trying to retry.
Yeah, but it's not actually bothering me for the end application, which is just every now and then I want a reading. So
yeah,
that's a rainy day project, not a all important.
Yeah, good idea to just reboot. Saves all the trouble in the world.
Ben, do you use MQTT on it?
No, I send a UDP packet with the temperature.
Yeah,
and if it doesn't get delivered, then I don't care. It can just
doesn't matter. Yeah, because I use M5s, which is based on ESP32, same as the D1 Mini there. And I came across a problem with MQTT that is not so much a bug in the library, but if you don't do the make sure that you do the quite correct sequence in the right way when you do the subscribe, and also when you're sending messages, you can get these abnormal reboots.
Yeah. I mean,
at
some point I'll put a terminal on this, connect it back up to a terminal, and see what the actual reboot error messages are. But it isn't even causing me enough trouble to bother
to worry about it. You got other things to worry about. Yeah, I know what you mean. Yeah.
But it came with these. The place I got also came with these cute little prototyping hats. So that's hold on. There's the device. There's the little prototyping hat. So that can just sit on top there when I eventually get around to taking it off the breadboard and prototyping it. And of course, my other favorite piece of hardware, Raspberry Pi, is my bike wheel with the Raspberry Pi in it, connected to IPv6, not to IPv4. bikewheel.hawaga.org.uk.
That looks like it's really useful. Can you tell me what it's useful for?
It's a when it spins, it displays patterns.
Oh, I see. Okay.
So it looks it's a sequence of neopixels. It's in a pulsing mode at the moment. But if you look at Richard's water softener had this strip of pixels down the side to show the level. It's essentially that, but stuck inside a bike wheel. So to use.
I have a question for you.
This is for.
So, I just wonder, what's your favorite form of NeoPixel? I know you have those little NeoPixel area lights. Yeah, which ones did you go for? Those just
this one is spiral.hawaga.org.uk, which you can control if you have an IPv6 web browser. Let me just change it. So that's a NeoPixel. The one in my bike wheel is actually dot star, but I like this form I'm getting a lot of mileage out of this form. I've got some more here that I've just been making and giving to people as presents, as fairy-like presents for them to put up in their house.
Can you provide a link to those? I was just looking at them just half an hour ago or before the meeting.
Yeah.
Just wonder if you could provide a link to which one you bought.
Yeah, I will. I'll find that and post it while the next person, if there's anyone else.
What do you actually drive them with?
So this one behind me is being driven. It's just clipped though. They're just clipped onto GPIO pins of a Raspberry Pi. I also have my first attempt at these ones are on my first attempt at a PCB running on a Pi Pico, but there's no network on this one. So there's just a little twizzle dial. So this is the one that I make and give to people as gifts for them to just flip around, lay around their house.
Nice.
But the one behind me is running a Pi Zero. And then
the one behind you there, that's just off pin. That's a 2812 running off pin 18, is it?
It's running on some pin. Who knows?
Yeah, pin 18 is the most common one, isn't it?
Yeah. Well, I mean, it's
there's 2 or 3 you can use, isn't it? There's pin 18, pin 14 or something.
Clip on. I'll show you the picture. Can you hold on?
Yeah. See that?
Well, there. Oh,
yeah.
Which way do I turn it? There.
Yeah. You clearly don't have gas.
I haven't mounted it yet, but it's you've got 5 volts, blank, ground, blank, pin. So whoever knows their pins. Anyway, there's no driver on that or anything. It's just directly connected. I've only blown up one Pi Zero that way.
Yeah, it's pin 18, so it's only like pin whatever 9 or whatever.
But yeah, this is my favorite hacking project. It's very relaxing to just sit in an evening and code some new pretty pattern for it.
Well, that's the thing is those strips. I like the strips, but then I realized, well, actually, you just have such a hard time putting into any sort of interesting shape.
Yeah.
Whereas
this one I intended.
You can sort of put whatever shape you want.
Yeah. This one I intended to make into a clock originally, and then I got completely distracted and over the top. And it does have a clock mode, but I never use it as that. I just let it rotate through this stuff in the evenings, and then have strange dreams when I try to sleep.
Yeah, it's like playing Tetris before you go to bed, isn't it?
Like playing with what before bed?
Play Tetris. I don't know if you ever.
Oh yeah, right.
I used to see square blocks and everything, rotating. Playing Tetris in my brain.
And the ATA 102s in your bike wheel, did you buy those as a bike wheel kit or a strip or what?
It's just comes as a strip, just a strip. So very much like Richard's ones are plastic. Let's see if I can zoom in on it. I don't know if
I've seen more.
Overloading that completely, or if you can see it. Oh no,
too bright to see.
But no, it's not a bike kit. The construction is absolutely horrific. It's all cable tied on, and then the electronics is in a Ziploc bag with more cable ties. So at some point, I'll move into the world of 3D printing.
Bikes are weight critical, Ben, so you can't get better than zip ties.
Yeah.
I've been finding it hard to buy APA 102 strips. Is this from AliExpress or where?
This was probably from Plymoroni, I imagine, but it was a year ago.
And do you drive them the same way as the WS or differently?
Let's have a look. I think well, it's different software because it's a different protocol. I did originally have a level shifter because I thought it would need a level shifter, and that was giving me trouble because I was driving it at such a high frequency, and I took it out and it works fine. So I think it's just tied straight onto an eye open using Rust, not Python.
Right.
Not bicycle Rust.
The thing in the middle of your bike, is that also LED or just
What was
sculpture?
that? Which bit? Hold on. Where? This?
Well, I can't see because of the screen layout. Oh, okay. It's your crate of bottles behind the bike.
If I keep
It
talking.
looked as though it was an engine compartment.
No, there's a lot of beer bottles.
Okay.
There's a particular recycling scheme you have to use in Berlin, which means that I end up accumulating them and only taking them back every now and then.
So every day.
Does anyone want to give me a hand with or hear about a way of creating a DAC on a development board? What I'm using at the moment is a PWM into an RC filter with an op amp to boost the level. Is that how we're all doing this? I can give you a couple more details if you want.
Nobody said just buy a DAC.
That's no fun.
Let me show you the application.
It's an interesting solution there.
Get the questions afterwards. So hold on. Screen share.
DACs are so cheap, aren't they? It's sort of.
Yeah, they're cheap, working I2C, so I just chop them in, and the basis that the Pi hasn't got it, so why not just add it?
Yeah, I use the 3008. There's so much documentation for it. It's ridiculous, isn't it?
Yep.
So have you got a picture of an OP495 there?
Yep.
Yeah.
Okay. So this is a quad op amp in a DIL package, and that's the price for 5. So they're about £2 a piece, which strikes me as not too bad for how versatile they are. I'm using a standard positive gain buffer like this. And the lovely thing about the OP495, which is why I wanted to share it with you, is it's operates on single-sided supply. You can run it at 5 volts. You can even run it down to 3 volts. It'll drive up to 18 milliamps of output current, which sounds great. And it's a rail-to-rail output. So it'll give an output from about 100 millivolts off grounds to 100 millivolts off your supply. So far, so perfect. And the input range is 0 to 4 volts. That's pretty good as well when you're running it on 5 volts. Then the real world hits. And this, as you can probably guess, is a graph of input voltage to output voltage from my positive non-inverting buffer. And it's tailing off, as you can see. And I haven't managed to suss out why. Now, what I'm driving it with is a GPIO pin, which I'm toggling using PWM, and putting that through a double RC stage. And the dark blue line shows you I'm getting a really nice linear output, because along the bottom there, I've got my digital values. And I can't for the life of me see why I'm getting this tail off, given that I've got a gain of about 1.6, so the input varies well within the 0 to 4 volts. And the output is, as you can see, struggling up to 3.9 volts rather than going to within 100 millivolts of the supply rail. Any ideas?
Sorry, could you clarify the bottom scale, 1 to 1,000? Is that a frequency?
No, that's a PWM value. That's a binary value on a scale of whatever it was, 1 to 950 odd. So in other words, I'm using about just under 9 bits of output to control my PWM.
So that's a frequency of 1s. you're talking about in the pulse width?
It's a mark space ratio.
Right.
So the mark space ratio here would be virtually 1, and the mark space ratio here would be virtually 0, or actually a bit above 0, as you can see.
Two shots, complete shots in the dark. One, might there be some sort of capacitance that might be filtering out the high frequencies, or the higher pulses, or is there anything to do with the sampling frequency, and maybe it's missing some of the pulses, and they're just guesses.
Well, they're good guesses because it does look like a typical roll-off, but the dark blue line is what my DVM is telling me I'm feeding into this amplifier. So that's looking at the results of the filtered PWM. It's a bit cheeky, I know, asking an analog question in a digital forum, but
can we see your? Can we see? Sorry, can we see the picture of what your circuit actually looks like? Is it?
Well, I haven't got it to hand or drawn up or anything, but that is most of it. It's just got a double RC filter on the positive input, and a single series resistor on the output to avoid overloading it.
Yeah, I mean, because the length of the wires might actually have an effect. I'm totally talking out my backside here, but you know, I think capacitance is one thing, and the length of the cables, they all, they all have an effect on this.
It's built in a tobacco tin, so the length of the wire is quite short. But yeah, I guess maybe there's some. I don't know. I've got a resistor before driving my load, so even if the load's capacitive, that shouldn't be too bad.
I don't know. But it's I mean, on PCB design, you've got all of this capacitance and inductance and all that kind of stuff, which I don't really understand. So I'm not even going to talk about that. But even how the wires are, how close they are together and stuff like that, they affect each other in some way. So if you're looking for precise readings, then I'm guessing that your circuit needs to be pretty precise in that way as well. In terms of how it's laid out.
Morris in the chat is suggesting maybe it's a fake one.
I think you've just hit on something. I really think you've just hit on something, because although the capacitance is low, maybe some of the frequency is getting through my filter, and so those capacitances are having more of an effect on the output than I bargained for. Because if they increase the drive current, then the thing will sag, because it's got 0.5 milliamp drive capability rail to rail, and the 18 milliamps is when it's in buffer mode. So yeah, I'll have another look at that. Thank you. The reason for showing you this is obviously to say I love the OP495. That's my piece of favorite hardware at the moment. But also, how do you guys solve this problem? I think while I was fiddling with this, you mentioned a couple of DACs you use or other circuits. Is that right?
Yeah, I mean, I think the one I use tends to be it's an MCP3004. It costs, it probably costs less than your OP495. It's about £3. Gives you 10 bits. I don't sample anything at any great rate, so that doesn't bother me. But I just chuck them in, and dirt cheap, dead simple. Works in I2C.
Yeah, I think they it's the 3008 work with SPI, so it's a bit faster.
Yep.
So I was using the 3008 at and I was probably getting 24 kilohertz or something on it. But one of the other guys got up to
go up to 150 or 160 or something like that. They're going close to the OS.
Yeah,
And,
I must admit, I use mine as sampling every 10 minutes. So mine is not high speed.
Yeah, I was just trying to build my own oscilloscope, which went okay, actually. It sort of gives you some simple measurements and things like that. So I could actually debug a problem I had.
Do you happen to know how close this device drives to the rails? Because I've got two key requirements. One is to go rail to rail, and the other is low power, because I'm spoofing another input device here and putting a microcontroller in and powering it off the supply to what should normally be a pod. So I need to be able to produce 4.5 volts out of it on a 5-volt supply. I can look it up.
Yeah, there's the 3008 ADC, and then there's a DAC as well, isn't there? It's sort of the same family.
That's lovely. Thanks for the lead.
So I built my oscilloscope. I put in a DAC so I could drive it to see what the ADC was doing. If that makes any sense.
This is a little oscilloscope I use. It's
Oh,
a
that's really cool.
self-contained one. So you
Ben, could you stop sharing?
Was Ben sharing? Didn't notice.
Yep.
Am I?
Yep.
You can control the voltage level that it's doing and things. Has two channels. So quite a neat little thing. Literally just plugs into micro USB to charge it up. Makes it very portable and very easy just to keep kicking around a workbench.
How much did that cost, Michael?
I can't honestly remember. About 100 quid, I think.
What frequency does it sample at?
I don't know the tech specs off the top of my head. It's a DS212.
Okay.
Yeah, I've looked at those in the past. I think they go to about 20 megahertz, so they're reasonably enough for what they are.
Oh, wow.
Yeah, they're quite. I think it's
That's
10 or
good.
20 megs. Yeah,
Maximum sample rate 10 megas.
Yeah, 10 megahertz. Yeah,
Mega samples a second,
Yeah.
I think.
yeah.
Good.
Analog channel bandwidth 1 megahertz. Maximum sampling storage depth 10K. So for what I need it for, it does a really good job. So
So what about you, Barry? What favorite hardware do you have? Must have some.
So I'll show you one here. This is my favorite bit of hardware, which is an M5 stack. I don't know if people have seen these before. So this is Arduino ESP32 based. They're a modular unit. You can plug up various bits and pieces. I've actually got this as part of my front door monitoring.
Oh,
It
nice.
links up to my Home Assistant. And basically what happens is when you lock the door, it turns red. So what the system does is basically, if the front door is not locked from 10 o'clock onwards, it basically sends me a message every 20 minutes via Telegram to say your front door's not locked. So it reminds me to do it. And I've also got a little heartbeat in there. I hope you can see that, which again, it regularly reports. One I can see visually, it's still working, because it's a bit like what we said earlier on about the D1, is sometimes these things just sometimes stop. And so it's helped with the diagnostics. And this has run now for 2 years, and it doesn't die at all now. But it also does a heartbeat. It actually acts as a heartbeat to my node, Fire node read into my Home Assistant, and it regularly reports it. So Home Assistant will actually report if it dies, because it will say it hasn't seen a heartbeat every minute. But what I've also done is a reverse heartbeat. This has in it basically MQTT and Telegram. So what it does is it checks on Home Assistant. So if Home Assistant dies, this actually sends me a text. So it's a double check either way.
Ooh.
So that way, at least if either device goes, I get some notification, as opposed to stuff has just stopped working and you're not realise until actually you go and try and use it. So I think these are brilliant. These are M5.
How have you detected if the door is locked or not?
So what in here you can see is a small cable going up, and in here there's a magnetic sensor. So I have a little one of those what was it, iridium, whatever, high powered magnets here, just stuck on the side there of the thing, and then
neodymium, is it?
Yeah, that's it. And then in here,
like a reed switch.
You can't see it. No, it's actually a solid state reed switch.
Okay.
And it works really well. So basically, as that closes in and it gets close, it then detects it and turns it red.
Neat.
So that's worked really well. But I love these. I did a similar thing on my previous cat door that would monitor the cat door, but the M5 range is brilliant. I think I threatened to do a little skit on one of these Pi sessions for Raspberry Pints on what M5 is and the ecosystem. So I should do that, because I think they're brilliant. And also they now support MicroPython. And they also have their own ecosystem of a visual thing called UFlow, which is a very visual base. It's a bit like Node-RED in the way that you do it, or like what's the Raspberry Pi one the kids use? Scratch, is it?
Yeah.
Yeah, it's very similar to that, and it's great. So I mean, I actually program in Arduino, but yeah, they're brilliant, and they're relatively cheap, and the smaller units are even cheaper, and they also have OLEDs in them as well, displays. So. That's my favourite bit.
They look absolutely great.
Sorry, say that again.
How cheap are they?
So that unit, at one time it was about 20 quid. Now it's about 30, but you can get the M5. What are they called? There's a small cube one that's about 10 quid. There's one with an OLED on it. With a smaller OLED, I haven't got it in front of me at the minute. They're about £13, but they are, and they come with a number of connectors on them. So you can very easily plug them using standard connectors onto there. And they've got a whole load of other little units, like the time of flight sensors, like fingerprint sensors, like it's a complete ecosystem. So they're very good plug and play type stuff. But the good thing is, because they're completely sort of open source in terms of the ESP range, you can, if the library's not available for it, you can normally get a standard ESP library working on it, because it supports standard I2C, SPI, all that sort of stuff.
I'll tell you what, Barry, I was just thinking, whenever I go on holiday, I always wonder whether I've left the gas on or not. Right, you know, if you ever get that feeling when you're driving off to the airport and you go, did I turn the gas off?
Yeah,
you know?
Yeah.
Can you do one for them?
Well, they've got a gas sensor as well that you can plug in via I2C, and then again you could use their UFlow and then set it up, or as you say, if you did some mechanical way of detecting,
it's like if you turn the mains on or off, you know,
or something like that.
That'd be peace of mind. Even when I'm abroad and I suddenly remember, I'd be like, you know.
Any physical things. I mean, I actually did this about 6 years ago using a using a basic ESP module, because my son was always worried when he used to live here that when he left the house, he'd forgotten to lock it. So I put this in place so that way he could actually see if he'd actually locked the house. And of course, every time you did, but it's always that sod's law, isn't it?
If you could have stuck something around his neck to give him an electric shock every time he forgot, you know.
Yeah, well, that's right. Yeah, maybe. Yeah, that might have been a bit too draconian, but that's where that originally came from. But I think they're a brilliant ecosystem, and again, they've got lots of support for MQTT. Oh, and I don't know if again anybody, because my favorite stuff is Home Assistant, and part of Home Assistant ecosystem is something called Esp Home, which is a standard environment where you can load a predefined image onto ESP units, either at 8266 or 32s, and it integrates really well with Home Assistant, and they support these as well. So it's you basically, you don't have to have as much programming knowledge, as you don't have to know C programming or Arduino programming. You use YAML, which are essentially like configuration. You use a YAML, which is a bit like XML, but it's not exactly the same. And if you use YAML, you then set it up and you can configure it. So you can load these up with a ESP Home. It talks to Home Assistant. So you can deploy these as very, very cheap sensors as part of your Home Assistant ecosystem. So again, they're very good. So yeah, and I keep threatening that I should contribute to this group, because so far I've been more of a leech than a contributor. So I should probably do something in the not too distant future around Home Assistant, ESP, and ESP Home, and these units.
I'll do that.
I think
now I've said it, haven't I? I've said it.
Yeah, I would love to hear about the M5 first, and also Home Assistant.
So November 30th is the next meetup, last of the year.
Right.
Sure.
Is it? But yeah, that might be a problem. And the reason is I'm actually on holiday in Bath on that week. So
it's okay. They've got internet there.
Everything's closed in the evening.
No, it isn't. They have a Christmas fair. That's why we go.
Oh.
There's a great Christmas fair, or 2 weeks long in Bath during that period. So sorry.
But it's all on Zoom. You can just dial in.
Yeah. Maybe.
By then, Barry, you'll have one of those indoor helicopter things that flies through your home and checks on the door and the gas.
Yeah, I know. Yeah, the dystopian future of Amazon. I know. It's a bit scary, isn't it?
You'll still be able to show us your door lock.
Yes.
Or somebody coming in, pushing through the door.
Well, I'll show you my favourite bit of hardware of the day, at the moment. Actually, if you're not up for it anymore, Barry, if you don't want to do next month, I'm actually in Budapest right now, so I shouldn't be bringing any hardware with me.
Oh, nice.
Right, but I've bought lots of little bits of hardware with me, because I can't live without it.
Well, I do that when I go on holiday. I do exactly the same thing. I bring M5. I bring a little portable Home Assistant setup that I've got running on a Pi. That's part of when you're away. You've got to have your tech with you.
Oh, I need it. Even it's like my little security blanket. It's
so cute.
It's no. I always think I'm going to get bored. So it's like, what am I going to do if I'm bored? I can't imagine, not tinkering with anything. So I bought some bits and pieces, and my favourite thing at the moment is a USB current meter that I've got. I don't know if anyone, you guys have ever seen any of these.
Yeah, they're great.
Yeah, you plug them in, and you can see how much current is being used by your devices, and as you probably know, or somebody might know, I've been inventing a device which I'm hoping that the battery is going to last for a long time, and so I need to understand exactly how much current these things are using. I could look at the data sheet, but there's nothing like empirical data to tell you what's going on. I think.
What do they cost?
Was it Anthony? Anthony mentioned earlier that sort of we looked at the data sheet and he says, well, it does this, but in reality, he measured it and it does something different. So, and that's where I'm at with all of that. So I've got one of these things, but something a little bit interesting that no one normally plays with is I've got this flash memory on SPI. I think it's SPI. Is it CS? Yeah, an SPI flash memory chip. Because you can get an SD card and you can plug that in, but I thought, well, hey, why do I need an SD card? Why do I need to go and buy an SD card when I've got a bit of flash memory? And so I'm going to play with that actually. in a minute.
So what device are you using? Is it 8266s or ESP32s?
I'm an ESP32 man at the moment.
Right.
And the new one that's come out at the moment is the S3. Which is really, I'm really liking that because it's got an ultra low power processor in it, which is I think it's Turing complete as well.
The other 32s did have it. The S2 didn't, I think, because that only had a single core. But the other ones do have low power.
Yeah, they do, but they're not Turing complete, right? Which basically means they've got a finite instruction set, and you can't do everything with it, right? But the S3 you can, so you can actually write.
That's interesting.
Yeah, you can write a full program. I mean, for example, you like. On the old ESP32s, you couldn't. You could have it in low power mode, but you could do really simple things like check the status of a pin, and you could just about do an I2C connection, right? But it's like, you know, in terms of logic coding and stuff like that, it's really, really, really hard, if not impossible. That's why it's not Turing complete. But the new ESP3 that's come out is Turing complete, and that means I can run some very, very low power monitoring. Yeah, that's the new thing I want. And also it means that you get an extra few I/O pins as well, so I don't need an I/O multiplexer as well for my projects. So that's the new thing I'm looking at.
Sounds interesting, that,
yeah. I've got a few coming. When they arrive from Mouser, you know, I had to join up to an early access program and stuff like that, but we'll see how that all goes. But yeah, I'm looking forward to that.
One thing I played about with quite recently, I don't have one like to hand, but oh, that's not what I was trying to do. It moved you all across. It's this little DF player. DFR 299. So it's a complete MP3 player on a little board that is under a $5.
Nice.
Fabulous.
All you do is you pop in a micro SD card, and then it's got you can either just pulse pins, or it's got an RS232 style connection. So the way I did it was I'd send it a command over RS232, and it has a busy line, and it pulls the busy line low while it's doing something, and then when it's finished it goes high again, so you know when it's finished playing something. You can then send it the next thing you want it to do, and you can load up a load of files. You can loop things. There's lots of basic controls. It's a little bit fussy about the like if you want to play when you're trying to control it in certain ways, it wants the files in a particular order to play them if you want to reference them by number. So it's got a few quirks to it, but if all you're trying to do is play a bunch of MP3 files, and the other thing is it's got a built-in amplifier, so you don't even need to amplify it. You can just plug a speaker onto it and it plays. So it's literally everything in one to play a bit of audio, and it does WAV files as well. So I actually loaded WAV files because they start playing quicker. There's less processing. So yeah, it's just a little fun thing. And the cheapest place in the UK that I found them was Rapid.
So how do you debug that thing? Because it's just like can't provide much information to it, does it?
Sorry?
How do you debug it? Because it's sort of doesn't look like much logging or any way of like knowing what the hell's going on. It doesn't work. What the hell do you do?
Yeah, I mean, honestly, I'm sure that was. I'll have to see if I can find it. It's to be honest, the protocol's pretty basic. It's literally a real simple packet that you send. So what I did was I found someone else's code and just stole most of that. I kind of took what somebody else had done and recoded it for the PIC chip that I was using to drive it. I'm not sure where I'll have to search for it. But yeah, there you go.
There's so much great stuff out there, isn't there?
Yeah, exactly. How do I finish? Oh, there we go. Stop share. There you go. You can all have your screens back. But I drive a lot of this stuff from PIC chips, just because that's what I started sort of doing hardware stuff on. And I find those really helpful because they're dirt cheap. They're under £1 for a processor, and you can do all sorts of stuff with them.
Yeah, how do you program those?
So what I've been using is you can use something called a PIC kit, which is one of these boards, and all it does is you can get them for a few quid off eBay or wherever. They're all clones, and you can buy some software that's up to date, PIC kit, something or other, for like 15 quid or something, and then you can program them in circuit with this. So literally, it's just a set of connections there onto certain pins of the PIC, and it will program away. It's just a USB connection. There's some free compilers I think kicking around, but I personally use the Proton Basic, which is you have to pay for, but it's not hugely expensive, and they do a free version so you can have a play around with it. But it just makes life a lot easier to code, because it's not like when you're dealing with microprocessors, the last thing you want is some of the complexities that go with, say, C or assembler, unless you can really know what you're doing. So I find it pretty rapid to pick up on some of my errors.
Yeah, easy access. I like that. That's good. I mean, I'm surprised I still got hair, actually, after all my years of assembler programming. It's
What about screens? What do people like for screens?
Do you want me to jump in?
Yeah, sure. Jump in.
One of the ones, hang on, I'm going to remove my backgrounds. Oh, you can just about see it's going blurry. This is like a combination. Ben mentioned the Wemos D1 Mini, and this little thing has got a Wemos D1 Mini inside it. And I don't think, hang on, let me just see if I can remove my filter here. Choose video filter, none. Come on, none. Did that remove it? No. Oh, damn. Okay, so basically it's got a Wemos D1 Mini in it and a bit of strip board, Aero board, and an 18B20 in it. And all it does is measure a temperature, and it publishes it out on MQTT. And I 3D printed a little box, and it's got a bit of foam in it to keep the electronics bits, which is over here, and which might generate a bit of heat, away from the actual sensor, which is over here, which is going to go out of focus again, and just printed it as open as I could. And they just sit and log temperatures for me. And I've got them in various rooms, and it forms part of my central heating controller. And the other key component in it isn't hardware, it's actually MQTT. And what it does is basically each of these little things essentially publish the temperature. And I've got a couple which have got DHT22s in it, so they publish humidity as well. And based on the various sensors around the house, it switches on the heating or not. And of course, MQTT means that I've got an app in my phone where if I'm away and I'm driving back, I can switch on my heating from my phone remotely. So that works quite well. Originally, I did an experiment where I programmed these in both MicroPython and C++. And MicroPython is a lot less reliable. I had basically I think I had about 5 of them all running at the same time. And the MicroPython ones might last a day, but generally not. The C++ ones just ran. So
this was on ESP32, wasn't it?
well, this was actually, these are WeMOS D1 minis, but I've done the same on ESP32s, and it's just exactly the same. They're just as I think it's the MQTT library is the problem.
Yeah, I mean, invariably, this is all down to memory. You know,
Yep.
If they're not managing memory properly, then they're just going to crash, right? If they run out of heap or stack or anything like that, they're just going to go and just vomit all over the place, right? So the best thing to do is take your measurement and then go to sleep or reboot, and then sleep for a bit, and then wake up and then and repeat and really, you know, rinse and repeat.
Yeah, the way I do it is just reboot every day.
Yeah, that'll work.
Yeah, no, I don't like rebooting.
For low power, this is the kind of thing I created. So it's got you've got the ESP module at the top,
yeah,
and then you've got a little PIC chip just here, and that PIC chip is the kind of the thing that is the almost like monitors the ESP module and talks to it, and will turn it off and on again if it needs to. So actually what this will do is it will turn off the power to the ESP module to send it to sleep. So when it's not needing to do anything, it literally just turns it off. The PIC chip goes into a low power state, which is sort of nano amps of power. And then a little while later we'll wake up, turn on the power to the PIC chip and to the ESP module, and off it goes again.
This is something you did, you say?
Yeah. Yeah.
You made that?
Yeah.
Why aren't you selling it?
Well, because it's for a very particular purpose. This was a custom thing that I was doing.
Yeah, no, but this is like, you know, you go on to this thing is
was
like
it for
all
the
over.
orb boards?
This is for laser tag. This was a Wi-Fi module to go in the laser tag guns.
Yeah, because that orb game you made for EMF camp had something like this in it, right?
Yeah, pretty much those boards are based off the orb game, which is sat in a box over there.
So the thing is, if everyone else finds this, but once you get obsessed with a piece of hardware, you keep using it over and over again.
Well, the nice thing is once you've done all the R&D on it yourself, you can literally copy and paste the design into your next project and your next project. So I was really, really upset. I don't know if you can see just there. It's pretty hard to see, but that's a 5-volt, sorry, a regulator, and it will knock the incoming voltage down to 3.3 volts. But it has quite a limited range itself. Like its input is up to, I think, just over 5 volts. But it will go. But it's a switch mode power supply that will pretty much go down to the 3.3 it's regulating to. So these boards are actually really flexible. I can run them off a 5-volt supply, but I can also run them off a lithium-ion battery, and it will work fine. But they've discontinued the buck regulator, which really upset me because it was really good. It was about, it could deliver about 800 milliamps at a very high efficiency. So I don't know why that happened, but
are there new ones available? Alternatives?
I don't know. I bought a reel of them.
So you're all right, mate. You're all right.
I'm fine.
And I presume you just did a custom PCB for that.
Yeah. This is just these ones. I think I designed in Design Spark, but the stuff I've done more recently, I've tried KiCad, and that seemed pretty good as well. So,
wicked. That's brilliant.
Actually, a talk on KiCad would be good.
Yeah, we're one not too long ago. I think Tony did one, didn't he? But another one would be good, yeah.
Yeah.
I guess that's a good question. Like, what do people want to see? I think the sort of skill ones are quite good, aren't they? You can sort of see what people have done, but then you can apply it to your own project and stuff like that. And punch ones are great as well, but it's good to have like.
So here's another little thing I made. So this is an iButton reader. So if you've ever come across these things, that's an iButton receptor, the wall panel mount, and then that's the circuit is literally just a PIC chip that does an iButton read and transmits the iButton signal coding out of the connector at the end. That's all it does. It's got a latch as well, which it does for something else, but that's it.
Wow.
Very cool.
Why are you not talking about this? Richard does a lot of talks about some really good stuff as well. So
then I made a smaller one.
Smaller.
Yeah, it's a bit smaller. Wow. So basic design
stuff, mate.
What's the iButton like compared to, say, RF tags?
Well, iButtons were kind of around before, and you can get a lot of different iButton types, but effectively they're an older technology, but they're pretty robust. Like they're designed to suffer a fair bit of abuse that I don't think you can necessarily give to an RFID card. But you can get them anything from just a serial number to being sort of having sort of SHA encryption systems on them, to EEPROMs, to all sorts of things. There's a thermochron version which actually tracks temperature over time and logs it into its memory, and you can then read it off via an iButton reader if you know the protocol. But they vary in price from like £1 or so all the way up to sort of 20 quid, depending on what the iButton does. My main purpose has just been serial numbers, identify who's there. So this is all part of a membership system. So on the laser tag guns, you just that sits on at the top of the gun, and you just tap your iButton on there, and it transmits your token into the gun, so it knows who's playing on that gun, and that way your scorecard shows your name.
Interesting.
But that's a whole bizarre thing, because I'm interfacing to sort of technology designed in the 80s, the laser tag system. There was no straightforward way to input the data into the processor, because it's already being driven high and low by the infrared receive circuit on the receive pin. So what I had to do was I actually modulate the signal into the IR receive circuit, because it is designed to accept an analog kind of signal in on there. So I literally just create a tiny little modulation wave of the signal that I want to give it, and that's enough to make it receive it. Unfortunately, the way it's designed, it multiplexes two pins together, so RX and TX are actually on the same pin, and if you drive the receive pins too low, it starts outputting infrared instead. So my first attempts of a membership token, I tagged in, and every pack around me tagged in as well, because it transmitted my signal out to all the packs next to me.
That's wicked.
Yep. So
but you live and learn, though, right?
Yeah.
That's brilliant. I love that.
But it's all PIC chips again, which again I've got the code already honed, working well. So reuse it.
Nice. That's wicked.
Very cool.
Oh yeah, some of the stuff they do there is really clever, actually, when I think of it. Like some of the things you can do, you can take, they've got like built-in peripherals, like PWM and stuff like that. But you can actually combine the peripherals together using logic cells. And so you can go feed a PWM in, but also feed in the serial port output into the logic cell, and then you can get a modulated serial output that you can just push straight into an infrared emitter. Things like that. So There's quite a few.
Sorry, that just went right over my head there. Sorry, I didn't understand a
Just
single word of
thinking for all of
that. I'm really sorry. I feel like an idiot.
Sorry. So infrared, the way an infrared signal is transmitted is you've got, first of all, it's the infrared LED that you use is at a certain wavelength, which will be like, say, 940 nanometers. So that's your light spectrum. Yeah. The way you kind of define whether it's on or off isn't, you don't just turn it on. What you do is you turn it on, but you modulate it on and off very rapidly during that period. So infrared signals tend to be either around the 36 kilohertz range or 56 kilohertz. That's the typical two that you'll find on remote controls. And all it is you just have to, whatever the actual infrared protocol is, you just, when you turn it on, you modulate it at the frequency that the system is designed for. So when I'm outputting infrared, what I actually do is I use that logic cell, I turn the PWM on at the frequency that I need to modulate the signal at, and then I use an AND gate effectively to merge the two together to give me one signal output. And because the laser tag system just uses normal RS232 style signals, I just merge it with a serial out, and so PWM and serial out combined give me a modulated output of the infrared signal that I need, and then I just connect it up via a like a BC549, a very simple transistor to drive the LED.
Okay. Do you know what? I get that now. Thank you. So you're basically, you've got two different signals going that, but if you add them together, they kind of, they're either 1 or 0, but if they're out of frequency, who knows what you're going to get at the other end. But, at least you can, if they're modulating at the same frequency, you should know what they're doing at the end.
Yeah.
Right? Yeah. Okay. I get that. Thank you for taking the time out to explain that, man. Because it just went.
It's surprisingly easy to do infrared once you understand the way it works, but the receivers are really simple.
Yeah.
I think you can buy like infrared drivers or something for Pis, can't you?
Yeah, you can get all sorts of. There's
like
Lurk for the Raspberry Pi, I think. That does the infrared. I have played around with that before. LIRC.
Remember that guy Avani? I forget his first name. Does all that open source hardware. He came and talked to us one time. Leon Avani. He does like a infrared hat, I think it is, which could be useful for some applications, if you just want to control your TV or whatever.
Yeah, I was going to say, actually, one of my biggest bugbears is my remote control for my TV doesn't reach the TV. Yeah, I don't know why, but I'm on the other side of the room. The remote control just doesn't quite reach the TV at the other side. Wouldn't it be great if I had a Wi-Fi controller, just like that could speak to an infrared device that was next to the TV. So basically I can control all my infrared devices from my phone, for example. That would be a cool thing, wouldn't it?
We've basically got one of those. I'm trying to think what it's called.
So I've got the one by Logitech, but I think they discontinued that now.
Okay.
Have they discontinued, did you say?
Yeah. Harmony. That was it.
Harmony,
Logitech
that's the
Harmony.
one.
Yeah, I think they've discontinued it.
Damn, it was good.
Yeah.
Well, I'm going to have to make one then. I'm going to have to make one.
That's it.
Yeah.
It's a good project to have.
Yeah. Yeah. I mean, it's next in the list. I've got one to finish first, and then I'll get that one out of the way. What's this?
Well, this is this Leon Navi that came to talk to us one time. He does open source hardware.
Uh-huh.
So this is the thing that he built, which is this infrared fat.
So it just, sets up the remote control for you. So it's really great because he provides all the necessary files to build your own. You just sort of pull it off the site, and you sort of have all the information you need to get the board built yourself. I think it's a useful place to start, even if you're just building your own board. You can sort of see what he's done. He's already debugged it and got it working, of course.
Does it have Wi-Fi?
Well, I think the Raspberry Pi provides the Wi-Fi.
Okay.
It's just the hat that's on top of it.
Right. Okay.
So, Gary, if you want,
Come again.
I was going to say, Gary, if you want a ready-built system, you need a Broadlink RM4. I've put it in the chat.
Okay.
It's basically an infrared and RF hub that learns, and you can control it with Alexa, Google, and an app on your phone.
50 quid.
And again, it integrates to Home Assistant and those types of devices. I've got one. I haven't actually properly set it up. I played with it, but I haven't properly set it up. But it's. I think that's what you're after.
That is exactly what I'm after. But I'm after a project that's going to cost less than 50 quid. Not that I'm being a tight ass or anything like that, but it's But I think it's more fun in making it.
Yeah, it is. Yeah, agreed. That's right. You could definitely make it for a lot cheaper. But again, it depends on the versatility of what you're doing. I mean, this has an RF component in it as well, where it will learn RF remotes as well. So if you've got other home devices that use RF, then the only one thing I haven't got it to try is to X10, which is the old home automation protocol. Yeah, I don't know if it does that as well, because I've got some X10 devices, but
I'll look into that. Yeah, thanks for that,
something
Barry.
to consider. Yeah,
thank you, mate. Yeah, no, this is all good information. I love this. It's like, the only way I'm going to learn is by finding out what's out there, and you guys are really helpful. So thank you, all of you. Really, it's great. It's amazing. I'm just looking now actually at what it does. So it's 4 through 3. Okay, but there's a few other frequencies. There's like 868 as well, or 866 megahertz.
There appears to be a family of them.
Yeah.
Which have more and less capability.
Yeah, because I mean, there's like LoRa, which is that low range or long range radio transmission, isn't there? And they run at 3 different frequencies.
Yeah, depending on whether you're in the States, Europe, or Canada. So yeah, I played around with those as well. There's a lot of fine tuning involved, and you're getting into having to know a lot more about analog signals rather than digital. But yeah, they're interesting fun. I played around with those when I was on holiday in York a few years back, and I managed to get just over a mile between where the apartment was and where we were in York. And that was just battery driven with some basic aerials, and that was an interesting experiment. So yeah, because the YouTuber, what's his name? The guy in Swiss guy.
West, maybe.
Yeah, that's it. Guy with a Swiss accent.
That's the one. Yeah.
He's done a hell of a lot of stuff around LoRa, and if you look at his stuff, really, really interesting. Very, very interesting. I learned a hell of a lot from him. So yeah, definitely recommend to go and view his stuff on LoRa. Yeah,
I second that. He's great. But so the learning about all those frequencies is good, because knowing what's legal in your country is quite important as well. But there's a lot of electronics devices that operate illegally, and they're sold as legal products in this country. I don't know if you know that. So a lot of the like Wi-Fi security gates and stuff like that, they don't use legal frequencies in this country. I found out.
One little thing that I've just got, it's tiny. I've got to give it a go. It's designed to learn those like garage remotes, awning remotes. So we've got a couple of kind of bits that come out from the above the windows. I'm going to try and teach it the remote controls for those, and then it can be you can control it from the I/O pins. So the intention is to stick that with a either onto a Raspberry Pi that's running Home Assistant and give it something extra to do, or some other device, and just be able to open and close the blinds via the radio signal. Because they're old, they're existing, but they're radio based. So there's no other way of interfacing to them, unfortunately.
That is that sounds like an ethical excuse for hacking there, Mr. Turner. It really does.
Oh, why not? I'm not going to be teaching my neighbours blinds to open and close. Unless they'd be pressing the button at the time that I'm trying to teach it.
I just hope you don't do that by accident. That's all I'm saying. You know, it's like that comes every time this one opens. Mine does as well. You know. We'll see.
Well, anyone wants to share? Need to close up, I think, soon. No. Cool. Thanks very much, everyone. That was good fun.
Cool.
Another good session. So we just have one more session this year, November 30th, as I said. You can provide a talk. That'd be great. But we'll definitely meet and have some more fun then. So we'll keep in touch via Facebook and Twitter, etc. Talk to you soon.
Yeah, brilliant. Nice
Thanks,
one.
Richard.
Thank you.
Thanks, Richard. That was good.
Thanks a lot, guys.
Cheers all. See you, everyone.
Bye-bye.
Bye.
Bye.
Thank you.
Oh.
Bye bye.